Hello everybody, I am Ben from Team Panic, and today we're going to be looking at plastic ants. Now, I know that the plastic ant class in America is a big thing with the plastic 1 pound ant weights, but ARC here in Adelaide has decided to convert its B grade class, as in 150 gram ant weight B grade class, which was kind of like a sportsman's class. We're swapping that over into an ant weight plastic class at 150 grams. Now, some of the people in my club were a little bit nervous about this because it meant that there was going to be weapons, like proper spinning weapons, in that class for the first time. So this has already happened. We've already had an ant weight fight with the plastic weapons involved, but nobody really used the rules all that heavily. So I thought while we're kind of in lockdown and everything's happening, I might try out a 150 gram plastic ant weight and see how much damage you can actually do in the 150 gram class with a plastic weapon. Hopefully, I'm going to assuage some fears here and people will be happier with this whole 150 gram plastic class. Now, that is actually what I designed this tiny little spinner for. It's a 90 gram chassis and electronics stack up, so I can put a very, very big weapon on there. Basically the biggest weapon you can put on an ant weight. But also, while looking online, I saw some people in the American classes using plastic saw discs, I'm assuming as like friction cutters. And I like this idea a lot. So I have brought back my Sawbot from last week, and I've also already kind of jumped the gun and I have printed out a plastic saw blade. This is an ABS solid print, basically. It was a lot of perimeters and then also solid infill as well. So hopefully we can just like do a straight swap between these two and have an actual plastic saw. I have no idea how well this is going to work, but I saw, like I said, I saw it, I think on Facebook, there was a couple of them, and I was like, well, maybe that will actually work. So this Sawbot still isn't the best. I haven't had a chance to upgrade it since last week. So there is still a lot of play in the arms and things. So this is not going to be the greatest test of a plastic saw blade ever, but it will at least give us some idea as to whether or not these plastic saw blades will work at this weight class. Here we go. Oh, and I'm going to need to file it out. Now, put too many perimeters in there. Anyway, I'm going to put this on and we're going to throw it into the arena up against the two chassis that we fought last week, and we'll see what the difference is between an actual saw blade and a printed one. So there you go, check that out. It totally works. I mean, this is a PLA chassis, so I was kind of expecting it to work against PLA because PLA has a lower melting point than ABS. But you can see, compared to the actual saw blade marks, it's pretty close. I mean, these Sharpie marked ones are the saw blade ones from last week. And then, yeah, this is the new one. It is more melty than cutty, but it does the job. You can cut someone with an ABS blade, which is hilarious. I kind of wasn't really expecting that. And the blade doesn't seem to have taken that much damage. Obviously though, as I said, that was just PLA, so maybe we should try and cut an ABS chassis next. Also, you might realize the electronics are hanging out. That's because I pulled the battery out because it got flat enough that the ESC was refusing to power the saw. So yeah, let's throw a new battery in, put some tape cover back on this thing, and yeah, try again, but versus ABS this time. Okay, wow. So that new battery has made all the difference. This thing, that was great. I mean, look at the back of this. Like, it has chewed all of this up. Inside here, where there is a little mount that kind of keeps the cables out of things, there it is. It's a nice big giant notch in the back there. Where the saw has gone amazingly deep into that. It's cut through a piece down over here where there's a bunch of hot glue involved. Obviously, when it got to the carbon fiber, it couldn't really get through the carbon fiber, which I was kind of expecting that because, yeah, the carbon fiber is not going to melt away like the ABS or the PLA. So obviously, considering the level of damage we got to in the ABS part, yeah, the battery issue was why we only got so little damage out of here, because this looks like it would have been a lot worse if I'd had a full battery in it. As for the saw itself, it's looking pretty good. I mean, the edges are now smoother. They're rounded off. The ABS print I packed too much plastic into it, so they were a little bit bumpy, and it's now smooth as, and you can see along the edge here, it's actually picked up like fused some green into the actual disc itself. So I'm pretty sure you need to replace this disc kind of every couple of fights, but considering this is like a 20-minute print and not a lot of material, that's something you could do easily, especially considering how much damage you get out of that. I mean, yeah, this mark down in the bottom here gets me every time. That's crazy. That level of damage for a plastic part on another plastic part, that's insane. Oh man, I'm so happy with that. Wow. All right, I was not expecting that to do anywhere near that well. I was expecting that we were going to need to move on to get some significant damage today. We are going to move on to try and get some more damage, but it's not going to need to be as great because, I mean, we've already done a decent amount. So the next trick, of course, is to do the overhead spinner. This thing can take a 55-gram weapon, so we're going to try and print something that is a 55-gram weapon. Here's the plan. So we have a top weapon bar, which is going to mount up where the pens currently are sitting, and it has some teeth indents here so that we can slide different impactors into it. Now, the big thing is this bar is printed in PLA. It's printed in PLA at 100% infill and also 12 perimeters. So it is really, really strong. It's also 30 grams on its own. These end caps are made out of ABS and they are also the same thing. So they're solid print infill, but then also like 12 perimeters or something crazy, some very high number of perimeters anyway. So the reason I've done it like this is I feel better about having ABS hit something than PLA. It's less brittle than PLA, but it does mean that the end caps are actually lighter because ABS is a lighter material than PLA. So PLA is making up this bar to give it a bit of strength and also to get the weight up there, because these end caps are only like 7 grams a piece or something. However, this whole bar at this stage is like 40 grams. It's not even the 50 grams that we need. So we might print some bigger ABS chunks later on to see if we can get even more damage. But just for now, I want to get this bar on the thing and see how much damage we can do with a 40-gram hunk of plastic. Wait, no, sorry. Before we actually do that, we are of course going to drive a pair of screws into the end caps here so that they stay on, because of course they can slide around, so we don't want them to slide during the spin ups. So I'm just going to throw a couple of self-tapping plastic screws in here, and that should help us hold everything in place so that they can't move or go anywhere. And of course there are recesses in the ends of these so that the plastic, or so that the screw isn't the thing that's hitting, it is the plastic, because of course this is a plastic class. No metal teeth are allowed on weapons. All right, let's actually get this thing in the arena now. And it looks like that one big hit is all we're going to get out of this current setup because, yeah, for whatever reason, the motor is now kind of on the way out. That hit pulled the bolts out from underneath it and I think stripped a couple of the threads. I put some longer bolts in to try and compensate, and now the thing just refuses to spin up under its own power. It spins totally fine when I do this, but trying to spin it up under its own power, it just refuses to do so. But we're actually underweight right now. We're like at 136 grams. So we've got 14 extra grams that we can throw into this, and that means we're not doing as much damage as we possibly can, because we did no damage in that hit. Both robots went flying, but there was nothing else going on. There's not even a mark on that other robot. But I also will say, painting robots with textures or markers, whatever you want to call them, is a bad idea. It's 2 weeks since I did that video, and you can see just from handling this thing, I'm getting texture all over my hands. So I'll probably have to gloss coat this with clear coat or something to stop it from doing that. But I'm going to go ahead and swap this motor out, put a new motor in it. And while it's doing that, I'm going to use the rest of this weight. Let's get some bigger weapon teeth on this thing. So the next clip was just going to be straight into the arena and spinning this thing up, but I had to show this off. Look at how ridiculous this thing is. Oh, these weapon teeth are massive. They are just huge. Yeah, just crazy, crazy big. And it is now like right on weight, 149 grams. So if we want to go any bigger on the teeth, which I might just yet, we're going to need to do something about this bar at the top, because remember the bar is like 36 grams total. So if we have more weight in the weapon teeth, we need to pull weight out of the bar. But that is optimal for impactors, because we want as much weight as far out as we possibly can. That gives us as much rotational inertia as it possibly can, which means the most kinetic energy, which means the biggest hits. So I'm going to throw this into the arena, get it spinning up, and let's hit something. So in the end, I caved and put a brand new motor in it. And even with a brand new motor, this thing struggles to get up to speed. Literally, you have to put the stick to about a quarter. It kind of gets to about like this speed. The ESC resets. You then have to push it back up to quarter stick, and eventually it will get up to about this speed, and then it will be good to go from there. So this level of weight with this much mass hanging off the end of it is actually almost too much for this little motor to handle, which is kind of hilarious. At the same time, it's doing nothing. This here that you would have seen in one of those clips, this is a transparent PLA print. Transparent PLA is really, really brittle, like crazy brittle. It should have broken this easily, which is why I tried it out, but it did not break it easily. As for the big brushless drive platform that I've been using to test with, that's the worst damage we've got. It's ripped some tape. That's about it. Oh, and it's pushed the silicon off one wheel. This thing I weighed down, so I was already overweight, but I had the battery out of it, so it was probably underweight again, but I've stuffed about 3 ant-weight weapons in here, so this thing is quite hefty right now, which means it shouldn't really go flying. I mean, it has, which means there is a lot of energy in these hits, but the impactors themselves aren't able to do any damage to the plastic. They're able to throw ant weights around, which is great, but they're just not able to do anything other than that. And it's definitely, yeah, what it looks like. This is unfortunately a little bit disappointing because I printed these already. These are another step up off of the ones that we have here. So they're just another couple of extra millimeters of plastic. And yeah, they would have pushed the whole robot overweight, but I also printed this, which is another crossbar, this time with some plastic removed from the actual bar itself, so that hopefully this whole thing would have left the robot in weight. But I think we know what the outcome of this is going to be. It's going to be near on impossible to spin up. And then if we do manage to get it spun up, it's going to throw the heavy test platform around and not break anything. I mean, these are just, you know, 2 shells and like 10% infill. If it was going to break, it should have broken already. This chassis was not printed for surviving a full fight. But, I mean, I have the parts and I have the robot. Let's just give it a go, hey? Yes! We did it! We got a tiny amount of damage. I mean, and it is really, really small. We took a chip out of the front scoop of that wedgelet. We also did break off one of the supporting pieces of plastic that holds the teeth in place. But, oh wow, did we fight hard to get that amount of damage. I mean, the blade that we ended up with on here is monstrous. This is way bigger than any ant weight has a right to have a blade on it. In fact, this blade, the original version, the smaller teeth version, was modeled after a beetle weight blade, and this is bigger than that. So this is a beetle weight sized blade on an ant. Obviously, it's also a 50-gram blade. So yeah, if you were running a dual weapon setup in a beetle, you could probably run 2 of these blades, although probably made out of steel or something. So that is an absurd level of plastic weaponry to get such a minor break out of our test chassis here. Yeah. So let me just say, from my testing here at the very least, don't be too worried about plastic weapons because I've worked very, very, very hard to get very minor damage. Unless, of course, somebody's coming at you with a saw. If they're coming at you with a saw, be very afraid. This thing is awesome. I might maybe run this. Maybe. We'll see. But having said all of that, I have come at this project as a let's take metal weapons and convert them into plastic weapons and see what happens. I could have done this wrong. So let me know in the comments what you think about this, and if you have an idea for a different plastic weapon or a different geometry for a plastic weapon or something, throw a comment down below. I might actually do a second video of this. If you guys give me some good suggestions, we'll throw them all together in a video and see if we can do better than a tiny sliver of plastic as our damage for the video. Yeah, obviously the other thing too is that these little motors they were maxing out hard trying to spin up this amount of weight. So I think in the future, when I put a massive blade on something again, we put a bigger motor on there, because yeah, those did not have a fun time at all. Anyway, I think that's going to wrap this one up, so I hope you guys have enjoyed that one, and I will see you in the next video.